Okay, so this is our physics project. See that string? It's on that chair. And on top of the chair, there's that weight thing, which is also on a string. And surprisingly enough, when you move the chair with the string and the weight falls. But what's it fall into? That's a golf ball in that box. That golf ball rolls down, hits the DVD collector set, into that book, into the other book. And that book hits the candle. But where does that candle go? Candle goes all the way down that ramp. It's a magnet. That's magnetized on something. But what's that white thing on the magnet? I think that's a string. And that string goes all the way up to the ceiling, through those hooks, and through that other hook, to then be connected to another weight. Then that somehow it just falls, and it hits the encyclopedia, which hits the other encyclopedia, which hits that book, which hits the other encyclopedia, which hits the Encyclopedia of France. That book hits a weight, which is then connected to those blocks that are shown right there with the duct tape, and then those blocks move back and then push the ball, and then the ball rolls down to a great physics grade. It rings the bell. That's all this does. It rings the bell, okay? Do you want to see it ring the bell? Let's watch it again just in case you didn't see it. The law of conservation of energy states that the total energy of an isolated system remains constant, and it is said to be conserved over time. In our example, energy is first given into the system by pulling on the string. This force causes momentum to the chair, which moves it, and drops the weight. The conservation of momentum is a fundamental law of physics which states that the momentum of a system is constant if there are no external forces acting on the system. In our case, the momentum of the weight was given by potential energy converting into kinetic energy. That momentum is then transferred to the box, which inside has a ball, and since the ball is not very stable where it is, it rolls out. But wait, there's more. There's also that really cool thing called the third law of motion, which states that every action has an equal and opposite reaction, and in this example, it's a double example, the weight hits the box, and the box reacts with an equal and opposite force to move that ball. Whoa! Now this right here is a great example of Newton's second law. Force equals mass times acceleration. This thing, it just rolled down and it accumulated enough force with its mass and it accelerated down and it just had enough force to knock over the magnet. So that's really helpful. Fun fact, that weight was accelerating downwards at a speed of 9.8 meters per second squared. Well, would you look at that? That's a great example of Newton's first law of motion. See, an object in rest will stay at rest, and an object in motion will stay in motion until acted upon by an outside force. So that outside force was the weight that knocked over that first book, and that motion put that other book in a motion, but then the first book's motion was stopped by the table, so it's no longer in motion. Yeah.